Internal BGP or iBGP. In this video, I want to talk about iBGP again and show you some details, some new details about the iBGP behavior. We have a scenario R1, R2, R3, R4, and R5. R1 resides in company 1 and R5 resides in company 2. And between these two companies, we have a service provider with 3 routers. The R2 and R4 are the P routers or provider edge routers, and R3 is the P router. This means the provider router or core router. Here we should use in service provider as a transit network, we should use iBGP. We talked about this in the previous video, but in this scenario we have another problem and we should talk about that and understand it. First, you should understand an important rule in the iBGP. It's so important to you know a rule, a special rule that we call it iBGP split horizon. Look at this scenario. I want to show you what is the meaning of the iBGP split horizon. Maybe one of the most important topics in the BGP or iBGP. iBGP split horizon rule. Okay, what is that mean? First, we should check two scenarios, and after that we can understand this rule. Okay, for example, I want to start from scenario in the left side. We have 3 AS and AS1, AS2, AS3, and also 3 routers resides in each of these ASs. Okay, look at here. We have eBGP between R1 and also R2, and also we have eBGP again in the link between R1 and R3. And finally, I have a BGP, eBGP again. I have another eBGP between R2 and R3. We want to check the behavior of advertising a route or a BGP update. Look at here. For example, we want to advertise net from R1 to R2 and again to R3. Look at here. R1 sends this update net A, okay, to R2, and you know that R1 should increment the AS pass or AS sequence in AS pass, okay, is 1. Now, after that, when the R2 sends this update to the R3, for example, to the R3, and here AS pass should increment it to 2.1. You know that when the R3 sends this update to the R1 net A, it should increment the AS pass to 3, 2, 1. And after that, because the loop prevention mechanism of eBGP that is based on the AS pass, R1 discards this packet. Why R1 discards this packet? You know, because R1 can see its AS number in the AS sequence of the packet, AS pass of the packet, okay, of the received BGP update. Because of that, R1 can understand that these packets generated in AS1 or passed from to AS1. Because of that, in both of case, R1 should drop or discard this update. You know, you knew these updates, but I wanted to review it to you. Okay, I understand that from the first videos of BGP learning, we talked about this rule, but in this time, in this scenario, I wanted to review it for you. And you know that R1 discard the packet, and this is the mechanism of loop prevention of eBGP. But what is happening in the iBGP? Look at here. Assume that we have iBGP between R4 and R5 okay, for example. And also between R5 and R6 here, again, we have another iBGP session. And finally, between the R4 and R6, we have another iBGP session, okay? 3 iBGP sessions. And again, we want to advertise a network, for example, net A, from R4 to the R5. You know that R4 sends these updates to the R5 if it's generated from its AS or it locally, the AS path or AS sequence now is empty. Okay, you know this because it's generated in the R4 or injected in the R4. AS path is empty. And the BGP update received with R5. Now you know that R5, for example, forwards it to the R6. And because R6 is the iBGP neighbor, R5 shouldn't increment the AS path. Yes, it's correct. After that, R6 sends this update, should send this update again to its neighbor, to its iBGP neighbor, and it doesn't increment the AS path. Why? Because the R6 and R4 are iBGP neighbors. Now, as you can understand, R4 doesn't know that this packet generated locally in R4. Because of that, it should accept this packet, this update, and again sending it to its neighbor R5. And again, R5 should send it to R6, and then R4, and then R6, R5, and now we have a routing loop. This means that in the iBGP neighborship, we don't have and we can't use iBGP, we can't use loop prevention mechanism of AS path. Loop prevention mechanism of AS path only can be used in the eBGP. Okay, this is so important. Loop prevention of AS path can be used only in eBGP, okay, not iBGP. Now we have a problem. How we can prevent of loops in the iBGP? This is the new problem that we have. We should solve it. The answer to this question is the iBGP split horizon rule. iBGP split horizon rules is a rule to preventing of loop in iBGP. How does it work? Let's talk about this. The iBGP split horizon rule is when you receive a BGP update from an iBGP neighbor, when you receive a BGP update from iBGP neighbor, you shouldn't advertise it to other neighbors. Look at here, to other iBGP neighbors. Look at here. R is a router, okay? And R has iBGP neighborship with 2 routers. For example, R1 and R2. R receives a BGP update from the R1 that is its iBGP neighbor, and because R also has neighborship with R2, iBGP neighborship with R2, it shouldn't send this update to R2, because if it sends it to R2, maybe this update turn and reach again to R, and R can't understand that this packet travels from itself. Look at here. For example, in this scenario, we want to prevent loop with iBGP split horizon. This means that when R4 sends the updates to R5, R5 doesn't send this update to other iBGP neighbor. Maybe you ask me, okay, with this method, how R6 can learn about the net A? It's easy. R4 itself